Yeah, okay. So today, I mean, we're mainly Emmanuel is going to work through JSL and Graph Builder. I presume, Emmanuel, there'll be lots of Graph Builder good things, plus the integration with JSL, right? How you can extend the features using JSL, perhaps?
I will do pretty simple stuff.
Okay, perfect. Okay. So yeah, so obviously, there's 35, 40 of us here. So, the most important thing is to mute your microphone. Session will be recorded and it'll be available afterwards on the Jump community. And if you have any questions, just pop them in the chat window, and myself, Mauro, and the others will try and answer them over the course of the meeting. So that's it. If you have any questions specifically about this community or about its organization, or you want to get involved, the four of us that kind of chair the group are here on the screen. You can use this QR code, or you can reach out to any of us via email or via Maria anytime you want. So that's it. So without further ado, we'll talk with Emmanuel now first, and then Jarmo for the second half. Thanks, guys.
Yep. So let me share my screen first. Okay. You see my screen, I guess?
Yes. Yeah.
So I will make a pretty simple and quick introduction about what we can do in using JSL for Graph Builder. So I will open the traditional tablet dataset and recreate this graph that I already saved as a script. And after make some comments about the kind of information we've got on it. And what I will do afterwards will be a colon switcher and a generalization of this script with a colon switcher. So a little bit on my side, a little bit of hard coding, let's say, but to illustrate the fact that you can do pretty simple thing, useful thing, but simple to code. So let's start by reproducing this graph. So it's about the meal time as an X, the solution as a Y. I think, so my default is that data points plus the smoother. So I will select the line here and add the equation. So all this additional information, and there is a last one, I will remove that one. So it's located here, show legend. So here, what I'm doing is not the default setting. So I've got this graph, which is similar to the previous one, and I will save the script. Oops, sorry, what did I do? I think I closed everything. No. Ah. Where am I? No, I'm here, sorry. So I will save the script as a script window. So you will notice here there is a certain number of information. What I will do, I will quickly copy paste just to illustrate that actually the minimum information, if I remove here the size of the graph, if I remove this information, if I remove that one, and if I remove all that one, and keep really the minimum of info, that will work. So just that information is the minimum. So typically you will never have such a limited amount of information, but that amount of information is enough to get something. And actually, basically, that was only having a Y, the solution, a X meal time. But after, you may have noticed, as I previously mentioned, I've got the default setting with the smoother, and I've got the panel here available. So when I did my first graph, I had additional information about the size, about the fact that I don't want to see the control panel, etc. So you don't need to know all those information, I would say, in terms of coding, unless you're really passionate about hard coding everything. What we always recommend is to drag and drop, do your graph and save the scripts, and starting from that, you may want to modify it a little bit. Just a comment on the graph by default. So I will resize just to have both graph and script together. So here by default, the axis has been automatically adjusted based on the data set. So as instance, if I go back to my data set and replace here mealtime 27 by a value of 50, and if I rerun my script, you will see that it will be adjusted automatically. And that's the benefit of this kind of script, that certain information are not hard-coded, but will be adjusted depending on your data. So that's really the goal here, that the data are adjusted based on real data. So you don't have to care about the axis. You just have to care about what you want to display, dissolution versus mealtime, and here to add a line of fit plus its equation. If I step back and put my 27 again, what you may want to do sometime is to log the scale. So it's what I will do here. I will log scales. And in that case, when I will save the script, I will save it in the script window and I will compare. You will notice that there is additional information compared to the previous one. So the previous one is as short as that, and the new one is much longer. What is very important here is log scale. So this additional line of script has been added.
Yeah, I'm just kind of watching this actually. Yeah.
And in addition, you've got all this information here, send to report. So when you see send to report, that's something that you may want to care about because that start to be some sort of hard coding. You may agree or disagree depending on how much you want to reuse your script. So here, really the point is to set to log the scale, to set the scales, and then it will be applied. So if I rerun that one, that will work. It goes up to 30 something, but unfortunately, if I change again my mealtime up to 50, you may imagine that will not be taken into account. It's not automatically adjusted against, it makes sense. In that time, I decided to log the scale and I decided to set the maximum value at around 30. So personally, I think that's something important to think about. Sometime you may want to leave the script as it is. The scale are automatically adjusted and it's what you want to do because you always want to have visually the data within the minimum and maximum value for both axes. On the other side, for maybe other application or different situation, you may want to have scale locked so that you see how the data points are behaving. So I would say it's a sort of visual automatic. If you are looking at a lot of data, you may sometime want, I mean, personally, I want it sometime to have always the same scale. So I visually see if the data are on the right, the left side, the upper or bottom side of the graph. But in that case, again, you have to be cognizant and careful about the scale because in that case, you would not have noticed with the log scale here that there is these data points far away. So I think what may make sense, for instance, is to maybe round those numbers and have a certain range, let's say 45, for instance. In that case, you would still miss the data points at 50, but something maybe like that. And a quick modification, you've got this kind of graph. That's maybe the kind of scale you want to use typically, and you will see if the data are moving from right to left, or again bottom or up of the graph. I will close that. I will close those graphs. What you may want to do, and it's what I will illustrate here with us. I should have stepped back to my 27, sorry. Up. Here you notice again that's automatically adjusted. What you may want to do is to do this kind of graph with a column switcher, and here I've added a slope, and here the mean plus standard deviation. So I will quickly do it. So graph builder, that's still my meal time versus my dissolution. I've got this line of fit with the equation here. And what I will add is a column switcher. So the column switcher is located here, redo column switcher. I've got meal time selected, which is my x-axis, but you can play on both x and or y-axis. Here I will just use the x-axis, and I will add all those variables. And what I need to add here for a categorical variable, screen size, I will add mean and standard deviation. I'm done. I will remove the legend, and I will save that script to a script window. So here, compared to the previous one, I guess you don't remember all the details, but it's very similar. I mean, from the beginning to here, that's exactly similar to the previous graph. What I have in addition is mean and standard deviation, and the column switcher. So the column switcher information here is totally new compared to the previous graph. And that's really the idea, to get access to this column switcher. What I would like to do now is to make this piece of script working for another data set. And I've got another data set ready here, but obviously it's a different data set with different variables. So the point is really to make it working even if I'm using a different data set. So basically, if I compare here the top and here the top, that's roughly, I mean, that's not identical, but similar. Here I've got the screen size, my first variable here, meal time. I did it slightly differently. I probably, I mean, when I saved it, I was not exactly at the same place, but rather than that, that's fairly similar. The idea will be to make it generic. And here I put the line of scripts that you will need to hardcode. So basically, the first one is to define your data table as current data table. So, I mean, we already discussed that in previous session. That's not necessarily the best way to define a data table, but for today, I guess that's enough. But again, what you need is to give a specific name. DT for data table is a bit too generic. Maybe a more specific name is preferable, depending on the complexity of your final code. But for today, that's enough. And what you need is to get the list of the column. So here, what I call column list should appear now. And my column list is really the list of all the columns in my data table, starting at API lot number to disso. Disso is equivalent to dissolution, but for any reason, in the data table store, there is the two columns, dissolution and disso. What I did here is to get the number of the last column. So it's n item column list. So it just counts the number of items within my list. So actually, I've got 21 columns. What's appear here? Last column is 21. And here for the graph builder, what I've added is chevron. DT, so I send a message to my data tables. That's something you already have seen. Here, everything is similar. And where it's changed is here about variable X and Y. So here you've got variable X, its screen size. Initially, that should have been mealtime. Anyway, it doesn't matter a lot. And here I replace by the information column list number 3. So column list number 3 means that the third column, which is actually mealtime, not screen size. And similarly here for dissolution, I replace by column last column. So here it's number 21. So you can use the name as I did it here, column list number 3, or the number of the column directly, which is here, last column, the number 21. You really have the two options, and here I wanted to illustrate with the two options. All those things are similar with no change. And where it's changed is here in column switcher, because if you remember, column switcher, you've got two information, a column name, here screen size, again, should have been mealtime, which is exactly the same code that I used here for the variable, column list 3, and the list of all my column names, which is actually just column list here, because it's already a list. So the list of column here is the simplest information to get access to. We already created a list and we want to reuse the list. How I know that it's a list is just because here it's using the curly brackets. So when it's using the curly brackets, and that's something that I already have been mentioned in previous session, it's a list. So here I've got the list of all my columns, and here column list is exactly the same thing, the list of all my columns. So if I run that on tablet production, I will have exactly the previous graph. Again, it starts at mealtime because that's the third column. And if I run this same script to my other data table that I will open now, car physical data, just a quick comment. I will then draw the relationship between all those variables compared to the last one, since my Y column was DISO in the previous data set, which is the last column, and here that will be gas tank size. So I need to go back here. So I need to select everything so that it defines that DT is my current data table, which appear here, car physical data. So that will erase the name of DT, which was previously tablet production, and that will become car physical data. But that will give exactly the same kind of graph. Similarly, it starts at the third column, which is type, and it's the y-axis is the last column, whatever the number of columns. You may have noticed that there is a less column compared to the previous data table. But again, as it works by drawing the relationship of the last column as a y versus all the previous column as x, it works similarly, whatever the number of columns and whatever their names. And we will have same kind of information and same kind of representation with line of fit equation here and mean and standard deviation here. So this illustrates that you can pretty simply start doing some JSL coding. And again, here, that's a pretty simple one. I've got a more complex one with expression, but that's not something that I will cover for today. But here you may notice that I had to change only here, here, and here plus adding this additional information here, and that makes the code from a specific code to a tablet data production dataset to a generic code which will work on any kind of dataset as far as the latest column is the one you want to represent as your y-axis. I'm done. So if you have any question, I don't remember if the question are for the end. Maybe that's the end of my my part. So if you have any question, do not hesitate. And if not, I will hand over to Guillermo.